our present this will be also recorded for future posterity. It'll be available on the website after the presentation. But our feature presenter today is Mr. Greg Spiegel from Redline Logic. Greg will be our main focus today is on AI and defense. We would encourage you guys, if you have questions during the presentation, please use the chat and then place them in the chat. And at the end of the presentation, we will have a live Q&A with Greg and the audience. And any questions that are outstanding at the end of the presentation that have not been answered during the presentation, we will address them then. But until then, I please encourage everybody to use the chat, and we will, well, we being me, I will hand it over to Mr. Greg Spiegel. So, Greg, show is yours.
All right. Thank you very much, Mitch, Allison, and Todd from the Pacific Northwest Mission Accelerator Center and the Defense Coalition for inviting me to do this webinar. And to the whole audience that's going to listen to this as well. So what we're going to be talking about is the evolution of AI in defense. And so we're going to kind of talk about a little bit of how to design for AI, earn trust, and enable decisions. So this talk is about how systems should participate in an AI-enabled ecosystem, not about adding an AI label to every product that we have. So I'll start with how we got here, then explain what industry should do differently, and then with the commander's need before they will rely on it. So I'll kind of pop through to the agenda, kind of give you an idea of what we're going to progress through here. So these
real quick, Rick, we don't see the screen yet.
Crap. See?
It might be helpful for the audience.
Yeah, maybe helpful. Okay, so there we go.
There we go.
So,
Thanks, Greg.
so I'll back up one there. And so this is what I was showing before. I'll show that again towards the end. This is our agenda. So now you can see what I'm going to say. And then we'll kind of progress through these 6 points. So thanks, Mitch, for bringing that before I got, too far along. Okay, so first thing is, who am I and why am I even doing this talk? A little bit about how I got where I am and why I have anything to say about AI and defense. I'm an electrical engineer by training. Graduated FSU with the degree in electrical engineering, but over 30 years ago, and I'm now an entrepreneur and a system builder. And along the way, I have done everything from designing and building military products, from the SINGARS radios through A320 amplifiers to getting involved with the U.S. Special Operations Command Joint Acquisition Task Force, which I've been in that role for about 10 years, which I currently am now the CEO of Redline Logic outside of there. So everything I have to say here has no bearing on what the government actually says. These are my opinions and experiences that we're going to discuss here, not anything that I can't speak for the government in any way. So these are going to be some of the lessons learned that I've seen over the past decade of working closely with the SOCOM innovation in the real world environment. So, so kind of what makes people want to innovate and then what makes people hesitant are some of the things that are now we're starting to see in the AI space as well. From that vantage point, the change in AI has not been one clean breakthrough. It's been a rapid shift in expectations of what we expect of AI, going from hearing little words of ML and AI, ML, and all the buzzwords that go along with it. So the next slide here, we will talk about how we've evolved, hearing about how AI and our expectations of it have evolved throughout the past 10 years, basically. Originally, AI was used to create good PowerPoints and presentations, those kind of things. It appeared in briefings before it appeared in anything useful. We started to see machine learning and computer vision being used for very narrow the real capabilities. Autonomy matured through integration, testing, and operational feedback. Then all of a sudden we saw LLMs and generative AI changed who could interact with AI. It became not only programmers, developers, technologists that were working on this in like MATLAB space to everybody communicating and starting to understand some capability of AI. So by 2024, 2025, the question shifted from should we use AI to how do we integrate it responsibly? So that's kind of how we got to where we are. And that shift created a predictable market response. Almost everyone now says they have AI. This was like the .com bubble, or, this every time a new buzzword comes about. So the question is, what does that really mean in the defense space? So AI is becoming an expectation, not a capability. So everybody is trying to sell AI. Everything has AI built into it in some way, either during the creation phase or during the operational use phase. Every platform claims to be AI enabled or have AI inside. Just like you saw all the internet enabled, cloud enabled applications growing during those phases. So the real differentiator won't be AI itself. It'll be how well can AI use your system. This is what we're kind of going to get into during this talk today is as technologists, as companies that are working with the Department of War, how do we enable our technology to, be used with AI if it isn't strictly an AI solution as well? So in a future slide, I'm going to define what I call design for AI. So this is what we're seeing right now, coming from when I was the lead engineer at the Joint Acquisition Task Force. We evaluate a lot of technology. Every single vendor is bringing an AI solution to the table, even for things that probably don't need AI. So everyone's bringing something, and it's including what their product does, but also now they're trying to show how AI makes that product better. But what we're seeing are these very siloed solutions. Vendor A has a solution going all the way from an end-to-end application to a sensor to whatever it may be. And this is not a fault of industry in any way. One thing I've seen is defense somewhat dictates that. It's a lot easier to buy an end-to-end solution than it is to buy a solution that has to work with other things necessarily from a contracts perspective. So this is somewhat a little bit of the dichotomy of acquisitions and defense. The things that actually we need are hard to purchase the way we need them right now. So my take on that is industry needs to help out in that. And that's where we'll get into a little bit of this design for AI. So each vendor, when they bring in a solution, they have a demonstration that works to show their thing, which of course needs that full end-to-end solution. The future is not fewer systems, meaning one company does everything. It's systems that can contribute to a common intelligence ecosystem. And that's where I think we should be looking as we look from a national strategy perspective to the future. So future is not more of these siloed AI solutions. I think there's a place for it, and this is something I'll talk about in some future slides. But what we need to do is make it so AI is being fed by all these individual siloed solutions. So platforms, maintainers, intelligence, logistics, analytics, autonomy, partners and operators remain distinct, the value comes when we start to have interoperability and information exchange between those, not from forcing everything into one standardized monolith system. It's sharing information will multiply every participant in it. So AI becomes that connective tissue across the missions, data, and roles, but it isn't a single source like brain solution. Even though it shows it in this diagram in the center, I'll explain how the architecture for the AI of the future will not be a single brain. So that leads to the design principle I think industry needs, which is design for AI. We've always heard of, as I was in the design space, um, designing amplifiers for the military and just in general design best practices. We did things called design for manufacturability and design for test or putting built-in test into our systems. These are methods and techniques that allowed our design to become easier to use, easier to maintain, easier to troubleshoot, easier to build. And that had to be done at the inception point of any good design. This is now what we need to think about from the AI perspective as well. So the analogy from all that is design for AI means designing a system today so that it can be useful for AI tomorrow. So not every platform needs to embed AI, but every platform should expose the useful facts that AI could use. Things like status, location, intent, sensor data, health, metadata, or time. These are things that we can combine together to provide AI what it needs in order to do its job best. By finding those commonalities between things, like time and location are probably, I would say, the most important thing when you provide sensor data or anything like that. It allows context to the data. Once the data has context, AI can start to process it better. So the systems will still perform its primary mission. It simply becomes AI usable. And that's the technique that I believe is where we need to be going. So putting good data in to a system that AI can see and understand will give us good decisions out. So once the systems expose what they know, that same information can support many different AIs and many different users. So those are some of the things we'll get into in a little bit later slides, but understand that those functions, those things, even if they don't use AI, just providing information to a place where AI can retrieve it and see it becomes of value. And I think from an industry's perspective, selling a platform that provides the information will make it so you don't necessarily have to provide the full AI solution. And I think that's going to provide value to your contract. Okay. So what do I mean by design for AI? What does it look like in real life if we do this? This is a really high level architecture look at what that would look like. So if we go from left to right, the systems are doing their jobs. They do what they normally do. You know, radar is detecting and tracking things. Cameras are observing things locally. Drones do what they do. They see and they collect information. They're running different tasks. Medics in the field are, you know, saving lives and things like that. Even things that don't necessarily you would think are AI connected can provide data to the systems. So all of those sensors, and people are sensors as well. That's kind of the medic example there. provide information on who they are, what they are, their health status, any sensor data that they actually have, the confidence in the data that they're supplying, and what their time and space is. So that way we aren't inundating ourselves with world data when we're focused on a specific area of operation. The idea with that is you provide a simple interface to collect data from pretty much any source. So I have a architecture called Bring Your Own Architecture that this kind of uh, goes in line with, but messaging brokers are very simple ways to send data to a platform and to a database. Very lightweight, could be used on embedded systems, mobile phones, all the way to GPU-based systems. So that data then gets supplied into databases that are queryable directly from AI. So I'm trying to avoid the modular open source architecture feel that everybody provides a checkbox for by providing an API. APIs are great, but they're not the most efficient way for AI to get data. So exposing queryable databases and file storages and video streams, those are four, including messenger brokers, are the four key components that would enable AI to work efficiently in the future. Then what you can do is provide the same information to different AI expert trained agents. The benefit there is you're not trying to make your targeting agent also be a medical agent. Everybody can access the same information, and those agents are trained by medics. The agents for targeting are trained by targeting. That will enable those agents to become better. The outputs of each individual agent work the same way the outputs of each of those individuals work in our current workforce. So by trying to assume that you have a single AI that knows and does everything, I think is not the optimal solution. Pipelines that route information to AIs, and those AIs then provide outputs of wisdom that then can be fed back into other AI agents, is where we start to go from data to wisdom, and therefore we can start making decisions. Some of these AI agents will take much longer than others to process. And so the data may come in later, but that is how a dynamic battlefield works. And we are used to dealing with that. But time critical AIs will stay small by staying very targeted to what they're meant to accomplish. They can subscribe to the outputs of other AI agents and make sure that as new information comes in, they can adapt and modify decisions or inform their users. This is where AI isn't replacing people, it's enabling and helping them do their job. So, but more information and more AI don't automatically create trust, especially for a commander who must defend a decision later. So this is one of the things that, as we're talking about enabling AI, we'll talk about trust. A lot of people, when they talk about AI trust, talk about hallucinations and what happens to AI as it starts to, kind of eat itself. From a commander's perspective, that's not always what drives the trust factor. If you're a commander and you're using AI to help you make decisions that are absolutely time critical, you have to make them very quickly, and you have to be able to make informed decisions to be able to process the most amount of information at any given time. This is where in defense AI trust really matters. The technical validation matters, but operational trust is a different question. A commander needs outputs that are reliable, relevant, timely, and specifically traceable. That means understanding the source, his confidence level, and relevance well enough to act. The practical standard for a commander is, can I defend my decision? When you use AI, you don't exactly know how it came to that decision all the time. Like you can't specifically pinpoint. And one of the things we see all the time, you can ask AI the same question twice and get a different answer, which is something that is going to slow down the acceptance from a commander level or even an operator level acceptance of AI. They need to explain that explain the speed without accountability will cause users to avoid the tool. The problem appears after the mission when someone asks, why was this decision made? So how do we solve this? How do we help this out? You ask AI a question, then you make a decision based on the output it receives. A commander then has this after action review. So when all the dust is settled, they have these reviews where people are going to ask them, how did you come to that decision? So if you rerun the same question and you get a different answer, the trust is damaged there. So a defendable decision requires traceable data, documented context, reproducibility, and an understandable rationale. So as that battle space progressed between your decision point and the after action review, the model has changed. The data has changed its model. Hindsight's 2020, but the decision has to be evaluated at the time that it was made, which prior to AI, that was a little more doable situation. So to make it possible now, we must capture more than that final recommendation. So when you put in your prompts and you're getting responses, that's not going to be all that's necessary. We need to be able to snapshot data at key decision points in time. So that way the ARs are defendable. So what does that mean? Like there should be a way to capture all the inputs and timestamps at a given time for people using AI in mission critical places. So that means capturing context, assumptions, mission rules, and the constraints. Being able to record the exact prompts or queries. From an operator standpoint, putting cameras on the battlefield were a big deal. Why? Not because they weren't useful or necessary, but because every question was second guessed. This is the same case. Most of the time, all of our police force and everyone's getting used to having cameras everywhere now. It's actually turned out to be a benefit for most AAR situations because you can actually see what happens. But in an AI space, we're back to that same point where people know that it's a useful tool, but also know that they can't fully explain what's happening at any given second. So recording the exact prompts and queries, record that model identity, version configuration, and all the relevant tools that it was accessing. Preserve the confidence scores, thresholds, outputs, recommendations, and reasoning artifacts. These are all things that we need to be able to do to support the commander utilizing tools. That way they can keep focusing on the mission. Sorry. So repeatability protects the trust, but the quality of the answer still depends on what we feed the AI. So trust will come from repeatability, but also our commanders being able to get results that they also agree with after an AER. So AI needs this ecosystem. So being able to process the most amount of sensor information and data we have. When does AI fail is when it can't access a good amount of data. The best AI is the ones that are provided the most amount of valid human checked data that isn't created by AI. So AI needs this ecosystem, kind of from the architecture I showed earlier. That is what will keep AI from becoming a monster. Providing accurate, real-time, useful information when we need it is going to be what is providing the most reliable AI. It hallucinates when it has too much of one type of data. So designing for AI will provide it the checks and balances it needs to provide the most amount of useful information. So feeding it doesn't mean indiscriminately dumping data. It means providing that rich, governed, timely information with those key things that link data to other data, which is time, space, any other things that creates a solid data ontology. So you can see here, just like Audrey, feeding the AI and keeping it happy is what we want to do. So when that ecosystem is available, AI becomes most valuable as a way to evaluate more options in a timely, available manner. So what does this mean? Where do we use AI in our everyday lives is to test out different COAs, different courses of actions, make AI iterate through the mundane things that we would love to do if we had more time to do it. AI doesn't make the commander's decisions for them. It helps them explore more of the options faster. When you're playing the what if game in a dynamic space, the faster you can iterate through the possible outcomes with the best amount of data, either through simulation or through real-time information. This is what makes it so you can start to decide things faster. So if you have the ability to check all the different courses of action, you start to put your priorities on, like if I'm designing a convoy thing to go to target B, and I look at all the different courses of action, there may be things that are higher priority that I need to focus on. You have things like fuel preservation, routes that have been cleared from IEDs, what time of day it is, what urban exposure you're going to have. This is something that a commander can start to set some priorities on, but let AI iterate through. So the best route changes are when priorities or conditions change. AI can quickly enable and adapt. Same way when you're driving and using Google Maps or Waze and an accident occurs up ahead, AI can help you figure out, hey, how do I quickly adapt my route? First inform that something has changed on the battle space, determine here are the next most available routes, and then let you choose based on what the main priorities are from the commander's intent. So the advantage is not one magic answer, it's faster iteration, better comparisons where you can ask the questions back and forth to compare the two routes, clearer rationale, and that gives you that overall lower cognitive load, which is something that we've been working for the past 10 years to remove from our operators. We put so much burden on them to process information and receive these informations while they're doing the hardest work possible. And then we second guess things later. So these are the things that we want to help them do their job better, as opposed to adding just one more layer of cognitive load on them. So AI compares things, you get to prioritize, and then you decide. So this is where AI needs to go. So that capability changes AI from a tool you occasionally consult into a persistent member of the team. So AI is becoming this member of the team. And this is one thing when I'm talking about AI agents, I'm not looking at a single AI engine. Every person with their own perspective should be working specifically with the AI that they will be working with in the field. Train as you fight, same thing. You should be training your AI with your specific perspective. um, which will allow you to gain trust, but also you're training the model on your own decision making, your own priorities and things like that, which will allow you to iterate faster when the time is short and tight. So humans don't have the time to read every report, feed, status update, or historical record. Most briefs are not brief, and everybody will skim through those things. But if you can actually let AI read every piece of data in it, as opposed to you going through and picking out your own perspective that you're used to seeing in a brief, this will provide you the confidence that you didn't miss something by knowing that AI read every single word in that document. Then AI can continuously monitor, synthesize, look for patterns that you might not have seen and bring those up. Allows you to compare plans and coordinate information. It can remind you, like at this point in this time, that a decision point should be made, and explain that. So it doesn't make people think faster. It performs the exhaustive review of what they would do if they had unlimited time to do it. You would sit there and read every piece of data when you have to make a life or death decision if you had time to do it, but rarely in those situations where you provided that liberty and benefit to have that time to do it. So so you as a user get to receive a trusted executive summary, knowing what matters, why, what its confidence level is in the data that's receiving, the risks, and what to watch. Um, the more you have trained your particular agent, it gives you that confidence to execute when needed, not just blind dependent. Nobody's going to say, well, AI told me to do that. They may say it, but that's not going to go very far. So AI gets to read everything, so the human doesn't have to. Hopefully, process the large amounts of information going by and be trained to pull out the specific things that apply to your specific time and place as you go. So all of this leads to one final conclusion about where defense systems are headed. So we spent decades connecting computers to networks. The next era now is connecting decision makers to intelligence. AI is not replacing every defense system. It's becoming that connective tissue between systems, informations, teams, and therefore decisions. So how do we close the chain between overloaded data? AI gets to read and synthesize that to a perspective of a person, providing that trusted summary output that then is quickly evaluated by a person who can make a confidence decision and therefore make a mission execution change. So as we create this ecosystem of AI, the future is not AI in everything. It's everything providing information that can be used by multiple AIs. So having it accessible is key, because then you don't have these very narrow visioned perspective AIs. You can utilize data from each point to improve your decision making. So more context, better decisions equals less noise and faster action. So that's my presentation. I'm happy to take any questions from here. We can go back to any of the slides as needed, but just want to thank everyone for attending and hearing my opinions and perspectives on this. So I'll pass it over to Mitch at this point.
I have to say the AI monster slide is probably my favorite slide I've ever seen in PowerPoint this year. maybe ever. So I'm definitely gonna make a copy of that for myself and just save it for my future reference because I could not agree more with how that was beautifully illustrated, showing just the differences between good AI and how you feed it versus not feeding it and starting for information. And more to that point, I know for there's probably a lot of people in the audience understanding uh, a little bit more about AI, but I want to talk specifically about use case. And I know you mentioned AI and decision making. Um, is there a tangible difference for we'll just think on the government side of things for the implementation of AI between we'll call it the strategic decision makers and then the tactical decision makers of the guys on the field. So there's AI implementation for we'll call it the generals, and then you have the AI implementation for we'll call it the team sergeants on the ground in there. Is there a tangible difference between how AI works between the two of those? Because uh, I'll let you answer that, then I'll follow that up.
Yeah, no, absolutely. And it comes down to swaps, all right, size, weight, and power. The commanders are usually in a jock, and they have access to, you know, infinite compute if you, sign a check that's blank enough for it. An operator does not have that. So AI has to be specifically designed for the place that is going to be consumed. If you get to the cloud and you have infinite GPU, which is currently right now pretty much restricted by your checkbook, that's one thing. You can have all the data. And if you're an operator on the ground, you don't have those resources. Even if you're at a fob, you are limited by your bandwidth. Every bit costs money. Every bit costs weight. GPUs cost, battery. If you're using like an edge compute device that's on your person, you not only have to carry it, that thing's going to be, getting hot where you don't want it to be, using up your battery that you need to use to communicate, and as well, every piece of equipment we put on an operator means one less thing that they don't have to carry to defend themselves with. So it's very different. Uh, those models need to be trained to be super small and efficient. And then what the ecosystem of AI should be doing is the cloud should be processing the large data and creating nuggets of wisdom that can be sent to the smaller AI to affect people specifically. And this is a way to make it so you don't need infinite compute at the edge, is by providing subsets of data and information that are specifically related by the time and space that they need to complete their operation. So I think that answers your question. But if not, I'll
No,
clarify
that
some.
absolutely does. I think I was part of an event earlier this summer that talked about edge compute literally for the end user devices and how everybody with AI implementation, they want to have the guys on the ground act like generals and where they have as much information as possible to make the best decision. And to your point, we have to teach both the end users and the AI models to act more like the team sergeants, where you give them enough actionable information. The information is solid, information is good, but give them enough information that's validated as good to make it go from just data and information to actionable intelligence that make the end users act upon the information. And to your point, let the guys back in the JOC, which for the people that aren't familiar with acronyms, is the Joint Operations Center. That's where all information is filtered into the theater commanders or the ones in the region where they take in all information possible from all the available sensors and then use AI to see, sort through and filter through information, and then use a human component of that to make decisions based on the available information once it's all been validated and brought through. Which, to some extent, that's the larger value of AI is to take away the mundane task of validating information and then decide what is actionable information and what is just clutter and data or noise, as they call it, mostly in the world of data.
Yeah.
Um, Secondarily, the other question I have on there is for actually, before I get that, there was a question from the audience. It says, outside of Anduril's Lattice, are there other vendors or existing DoD formats or for vendors that they use?
So yeah, so this is what you don't want to fight the system, right? Like, so in the design for AI space, choosing a single vendor and who's going to win this is a betting game. You're going to go into the casino, place your bet on, Lattice or whatever. So at the end of the day, it doesn't matter who wins, right? Or what is the end platform that they use. Once sign yourself up to that, you're at the whim of the government and contracting. But the point is, exposing information, once it's at a database level, it doesn't matter. Like Lattice can ingest all data the same way Elasticsearch can ingest all data. Like if you need structured query language, like these are easy ways to get into a system and make yourself tactically relevant is by saying I'm exposing my data directly for transform into whatever the comp platform is, the common operating picture platform. If it ends up being Lattice for your end user or customer, okay, fine. But set yourself up to work with those systems as opposed to trying to replace them with your own overall system. So I would say focus on the end user. How do I provide the person that your system is designed for the most relevant information, but expose it to what's going to be AI. So it's twofold. So you have your own databases that and your own, you know, operations and all the things that go along with your own architecture, but be aware that you are going to share the information with the larger systems. That would be my tactic there because I've literally watched the government go back and forth between who and what is the platform that will be used, putting yourself in TAC. You don't have to create plugins to do that. You can expose your data and send data to TAC. That's better than spending all this effort to create a plugin. Uh, that's the key there is what is the minimum effort required in order to get your relevant piece of information into the battle space data. So that's not a good answer, I know, because probably people want to know where to put their chips.
No.
Um,
The
Lattice.
yeah, the question came up from the same person that did the TAC. I believe Greg's referring to the TAK, the Technical Awareness Kit,
Yes.
which is it's an end user device suite. So it's based on it's more commonly referred as ATAK, so the Android Tactical Awareness Kit. There's also now ITAC for the iPhone users, but predominantly the government systems work on Android, so they use ATAC. So essentially, what TAC is, it's an application that can be used on end user devices such as tablets or cell phones that the individual users on the we'll call them the tactical edge, the guys on the front lines, they have an awareness app on these devices. They're able to see situational data. It takes input feeds from both the radios and other connected devices such as GPS, whatever else, and it feeds information into the end user device. So it paints a larger situational awareness picture for the person on the end user device and all the connected users that have access to the device. It started out for platoon commanders and platoon leaders throughout there, but now it's so prevalent, especially in the SOCOM community, everybody's plugged in and has those devices literally strapped to their chest or in their pocket that at any given time they could pull it up and see what's going on in the space around them.
Right.
So, and in the tax space, it's literally an app. And a lot of people can go on there. It's I don't want to misspeak. I believe it
TAC.
is open source.
Yeah. Yeah, there is a CivTac version, and
Yep.
so you can download it and yeah, it's open source. You can create your own server to test things out and that kind of thing. So
Yep. Uh, going back onto the AI component, I know again, the illustration of the bad monster of AI and feeding it bad data, what safeguards can people put in place to ensure that the data they are feeding their models is good? Obviously, the provenance chain when it comes to data, and I mean, good data in brings good data out, and how do users want to safeguard that, especially now that there are outside factors that could go into essentially poison pilling AI models purposely giving bad information into the open source world out there, how can users ensure that the data the AI is being fed is good?
Right. Well, I mean, AI is all about weighting, right? It's different weights. So by designing for AI, not only are you putting um, some of the ability in the data itself, meaning what is my timestamp? What is my location? Where is the sensor information coming from? Those are things that can be validated and should be validated, which will allow AI to properly weight things that are not, OSINT or open source information. I would much rather pull information from an operator on the field, from his ATAC device or sensor on him. I will weight that more than I will weight something else. So we have the ability to provide confidence levels on the data inputs. And these are things as we're training AI models, we have to put the proper weights on data that is coming from, your relatives, basically. What your mom says is going to be a higher priority than, what some acquaintance says. And AI works like that as well. So you have the ability to weight your data. And this is where the starving AI monster image really happens. If you ask it a question that your mom doesn't know, it's going to go out and ask the internet, and that's where having lots of good data that you have high confidence in will provide you the best output. Once you let AI start to go, figure things out on its own, yeah, that's the kid running with scissors.
Speaking of kids running with scissors, I just think for the benefit of the audience, Greg, uh, everybody has heard of AI in various forms these days, and a lot of people are familiar with AI and they associate AI with what we would consider more of large language models with like Gemini and now everybody's come up with their own version of that. Can you speak to the distinction between the large language models, AI, and even autonomy? Because some people may confuse all three as the same thing or being synonymous.
So autonomy is a fun word because it's still in the process of being defined. AI is still very broad. Same thing with autonomy. Autonomy right now is what happens when the user is disconnected is autonomy. So in the world of like unmanned systems, those relate down to behaviors. So what is the unit's pre-programmed behavior? And those behaviors are what are defining its autonomy. So if you have a drone that's going to go out and hunt for, a certain truck, now its behavior is going to be to come up with some sort of search pattern for a given area and rule out everything that's not that truck. And then when it finds a truck, it's supposed to do something. So the autonomy piece of that is the expectation of what this, certain platform is going to do um, once it's been told to do something, and then it's either going to report or do something else once it finds that data. So that's really where autonomy is what I would define autonomy. Like, of course, I'm not the end all be all, but this is what I've seen in the world of DoD. Is it starts to come down to asking what is the behavior of the platform. Now, large language models, those are a way for us to interpret our operator intent and translate that into um, mission intents. So it gives us a way to not have to memorize all the commands. It's like working with, Google Home automation before, where you had to specifically tell it, and use keywords in a specific order in order to accomplish a task. An LLM then takes your natural language and determines that order and creates that. So it's a progression of an if-then statement into a what if statement. So autonomy, I would say, is defined by a set of behaviors that are attached to a platform or whatever it may be. Autonomy could be, you know, you having Copilot, answer all your emails for you in the morning, and you know, it's going to be based on those behaviors, like clear out this inbox as fast as possible by, sorting that stuff. So that's a behavior that you're doing, and that's what I would consider autonomy when there's some sort of tasking, a measure of success, and some basic rules to define the outputs there.
And autonomy does not specifically mean without human component of there. It just means that's the actions it can take without human input or oversight in the event that the human component is either disconnected by force or by whatever natural phenomenon. It just means that there's actions pre-programmed into the system to take actions in the event of
Right.
whatever trigger event happens or it encounters based on what the sensors are telling it.
Right. No, it's absolutely that's really where autonomy right now is the big buzzword is in a denied communications environment. When the user is disconnected or when, what will it do when the user goes and gets a cup of coffee or something? It's then, is it going to just sit and wait or is it going to work on something, till it comes
Continue
back?
on mission. Yeah.
Yeah. I'm like, I'll tell ChatGPT or whatever to create a slide using Audrey and and then I'm gonna go get a cup of coffee and I expect it to be done when I get back. So, there's a level of autonomy in an LLM. I've given it a task and it's gonna go do all the things and you can sit there and watch it dipping and booping, or you can just wait for it to be done. So, but it's what it does until you can enter your next prompt pretty much. So that's where LLMs and autonomy connect together.
Very cool. Well, thank you, Greg. I just check in, make sure there's no outstanding questions in the chat. So, last call for any comments or questions for Greg while we still have them. Um, I said I'll just close by saying this is fantastic, and I sincerely appreciate this, Greg. This was a treasure trove of information. And again, I'm stealing that slide. I'm going to, if I don't print it off and hang it on my office, I'm going to at least keep it on my on my computer, share with other people. Just when they talk AI, it's like, hey, look at this. This explains exactly what you need to do and have design considerations and what it is you're talking about. Be more educated on that. And I think that was, I mean, absolutely worth it just to watch that. So again, thank you, Greg. So.
Absolutely. I'm glad I left that one in. I was like, okay, is this a little too cheeky? But I'll put it in there. So I'm glad I did.
Yeah. One is one question. It says, any specific format we should set up the data for input from defense? We talked about output for the data.
So, yes and no. It's at a point, as long as the data has where it came from or who, some way to know and identify your sensor or where the data came from, uh, where the data applies. So whether it's a GPS location or whatever, and a timestamp of the data effect. So not only when, uh, so two things, when the data was taken, and then maybe also when it was reported. But really, JSON or any, you know, protobufs, any of those things are totally fine because they're readily ingestible. So for video feeds, RTSP streams are the best. I can make an RTSP stream show up in TAC and be able to be seen by a end user in literally 30 seconds. So if you're providing a video stream, look for the standard outputs of things. What is the standard file formats that most people use for whatever the data is, and provide it in that. Those are things that AI already can ingest easily. There's easy conversions and things like that. So this is what we should be making computers do, is do this back and forth translation and stuff. Um, so it really doesn't matter as long as it has a format that is consistent and ingestible. Main key thing is related with time and space. Probably the most problematic thing, because then what time zone and all these things, but those are the things. As long as a computer can decode those things to know where your data is relevant, you're 90% there.
Very cool. And also very, I mean, that's a great answer, honestly. So that's hopefully, David, that was a sufficient answer for your question. I think great answer. Yeah. Agreed, David. Great answer. All right.
Sounds
All right.
good.
Last call in three, two, one. All right. Thank you, everybody. Thank you sincerely to Mr. Greg Spiegel at Redline Logic. This was a fantastic presentation. I would say stay tuned for future business innovation events. Please check the website at pndc.us for future events. We will have one next month featuring the Idaho National Laboratory. Um, Greg, you're welcome to join that one too if you're free. But
Great.
for everybody else, thank you for coming. You don't have to go home, but you can't stay here. So thank you, everybody, and have a great rest of your day.
Okay.